Good night. Here we are, the group number two, and we are going to explain the laboratory experiment that is shear stress in beam bending. So first, about the abstract, this experiment investigated the behavior of shear stress in a simple supported aluminum beam with a concentrated load in the mid. So for this, we use gauges installed in the neutral axis and in the upper flange. Also, we use the Morse circle to obtain the value of gamma to calculate the theoretical shear stress. And this experiment was useful to understand the shear stress distribution and the effective breadth of the in-beam bending. So for the introduction, we have the beam bending is one of the most important topics in structural mechanics. About the beam is aluminum that has a I shape. The objective of this experiment was to investigate the shear stresses developed in a supported aluminum beam and compare the theoretical values obtained by using the Morse circle and the experiment values using the Morse circle and the other values obtained with the typical formula. For this, the experimental setup was first the beam. We also used the string gauge and hydraulic loading system with a load cell to obtain the value of the force. Uh, the instrumentation was the string gauges. Additional, the string reset used for obtaining gamma. Thanks.
So right now, I'm going to talk about the data processing and calculations. First, with the low cell calibration, we measure to determine the relationship between the sensor output and the applied force. With this data, we made a linear regression analysis and we obtain a coefficient of determination really close to 1. So we confirm that the linear behavior and reliability of the measure was correct. Then, with the more circular analysis, with the strain gauge rosette, we obtain the strain in X, Y, and XY. And with the circle of Moore, we determine the maximum shear stress strain for the circle. Then, with the for the theoretical shear stress calculation, we only apply the formula of the shear stress. That is the shear stress times the first moment of inertia divided by the inertia times the V of Y. Then for the experimental shear stress calculation, we apply the Hughes law, that is G times shear strain XY direction. And for the effective breadth evaluation, we measure along the flange to evaluate the effective breadth of the section of the beam. And we obtain the experimental values from the strain gauge were processed, and we use the regression analysis and the numerical evaluation techniques. Thank you.
Well, and now I'm going to talk about the results and discussion. The first part that I want to talk about is the load cell results, because after we put all the values that we obtain by the string gates, we can make our force be time graphic, and we make the linear regression. We have a very high R square, and that calibration results show us an excellent agreement between the measure the signal and apply the load, confirm the accuracy of the instrumentation system. And moreover, in the case of the more circle results, the data was obtained from the string out from the rosette, and we proceed to make the more circle using this data. When we make the more circles, the analysis that we have allow us the determination of the principal strength and the maximum shear strength that acting in the measured location. And as you can see, this is the graph of the Moore circle that we obtain after make all the process. This graphical no, in the part of the shear stress comparisons, and this experimental shear stress, it was obtained from the measure of the shear strengths. And now the general trend was consistent with the theoretical expectations. And now this is the table of the data recovery that we obtained. And finally, we have the effective rate results. And basically, the strain distribution was measured along the flange, and we use regression analysis again, and we show non-uniform strain distribution across the flange. This distribution across the flange confirmed that the strains were not uniformly distributed over the entire width. So that's all. And thank you.
And conclusion, number one, the experiment successfully evaluate the shear stress measure of a simple support aluminum I-beam subject to a concentric load. More shear analysis allow the determination to shear strain for the strain gauge rosette measurements. Experimental and theoretical shear stress values showed similar trends, although some differences were observed due to measurement uncertainty and the experiment condition. The strain distribution measure along the flank was used for evaluating the effect bearing of the beam section. And the recommendation an app the node graph to avoid sudden variance in the record measure. Number two, reduced vibration generated by the hydraulic loading system. Since strain gauges are highly sensitivity and external distress bands may affect the accuracy of the resultant finds. Number three, repeat the text several times to improve the reliability of the experimental data.